So we have graphing square root and cube root functions. This is the parent function. So everything comes from here. In this form, there is no stretching, reflecting, or horizontal or vertical shifts. So you can write an NA in those three boxes. I'm going to go over two ways that we can graph this. One is understanding the input and output, and the other is using a calculator to retrieve the answers for us. So just like I said before I started recording, if I plug in 0 for x, the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. Now, although there is a square root of 2 and a square root of 3, they're not nice integer answers. So I'm going to bump up and do the square root of 4 and the square root of 9. So I'm going to go over 4 up 2 and over 9 up 3. Connecting those points with an arrow headed to the right. Recall that square root functions, when we're graphing on a real axis, we're not going to have imaginary answers. So we are not going to take the square root of a -16 or -4. We're not going to have those I answers. This is only real answers. That's why nothing exists in this region, okay? All right. Cancel out for me the top part, which is the end behavior. So domain. Domains describe x's. It starts at x equals 0. It's actually touching x equals 0, and it continues to move towards the right. Domains go from left to right, describing x values. Ranges go from bottom to top, describing y values. So from bottom to top, it starts at y equals 0, and it continues to go upward. Starts at y equals 0 and touching that point, and it continues to go upward. For this function from left to right, is this function increasing or decreasing? So I'm going to put an NA for decreasing. And remember, when we describe increasing or decreasing, we're doing it with x values. So really it starts at 0 and it continues to go to the right where it is increasing. Is it increasing at the exact point of 0? It's starting there. Bless you. Bless you.
Thank you.
It's starting at that point, so we have our parentheses. Okay, the real zeros. Now this is an easy one just to visually see. We have an x-intercept, or a real 0 at x equals 0. As an ordered pair, the x-intercept is 0, 0, and the y-intercept is also 0, 0. As this function goes to the right, as this function moves to the right, is our graph going up, going down, or staying consistent at one number? And then actually it's gradually moving up, so it's going to be positive infinity. Go down to the next one. Since there's not a negative in front, there is no reflection across the x-axis. There's no stretching or compressing because the number in front is a hidden 1. Again, greater than 1 is going to be a stretch, and if it's between 0 and 1, it'd be compress. There is a horizontal and a vertical shift. It shifts to the left 3, so left 3 units, and it shifts down 6 units. Okay, I'm going to go over two ways to do this. Okay? Here's the very first way. Please go left 3 and down 6 and make a dot. Pretend like this is your new origin. And since there's not a reflection or a stretch, I get to come right back up to these original numbers and think of this as a pattern with square roots. 0, 0, 1, 1, 4, 2, 9, 3. 0, 0, 1, 1, 4, 2, 9, 3. Again, where did I get those points? From the parent function. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. I'm going to go over an alternative method to graphing as well. We get to use that exact same pattern as long as there's not a reflection or a stretch or compress. When that occurs, I'll teach you how to do it without using a graphing calculator as well. Okay, so I have my function down. Let's talk about the domain. Domain is in terms of x values. It starts at x equals -3 and it continues to move to the right. Domain is always left to right. Range is always bottom moving up. So the range starts at a value of y equals -6. It too moves upward continuously. From left to right, is this increasing or decreasing? So I'm going to put an NA for decreasing. And it increases, remember, increasing and decreasing is in terms of x values. It increases from -3 and continues to increase to the right. Whenever you find an x-intercept or a real zero, y will always be 0. And likewise, whenever you find a y-intercept, x will always be 0. So here's algebraically how to do that. As you recall, f of x is the same as y. So I'm going to substitute 0 in for f of x to find the real 0 and the x-intercept. I'm going to plug a 0 here. And some of you will be able to do this using mental math and not have to show any work. The first step to isolate the x is add 6 to the opposite side. To cancel out the square root, you're going to square both the left and the right side. To isolate the x, you'll subtract 3 from both sides. X equals 33. Written in an ordered pair for the x-intercept is 33, 0. I'm going to use a graphing calculator to make our life easier for this particular problem. Let's come over here and answer this. As we analyze, as this function moves to the right, is the graph going up or down or getting closer and closer to a constant value? And the answer is slowly moving upward. Take your graphing calculator, please. Do second plus 712. Be careful of your parentheses here. So we're going to do second square, oops, sorry, my fault. Y equals second square root, x plus 3 in parentheses, and then subtract 6. When you're done, hit graph. Do you agree the two look similar? Okay, so they do look similar. All right, so here we go. So I'm going to try to teach you again. There's more than one way to graph. So this is understanding the parent function like I did it. Here's what I'm going to call like the dummy way to graph things, and this works okay. Ready? Do second graph. I want you to continue to push upward until you see the word error. We are only going to graph ordered pairs that both contain an integer. So -3, -6, that's where I'm starting. I'm starting right after the error. -3, -6, we already graphed that. -2, -5, we already graphed it. Move down. 1, -4, graphed it. 6, -3, graphed it and connected. Done. How do you know where to start? You're starting with the square root. You're starting after the word error. After the word error. Now here's why it says error. We're going to do mental math. Carlos, help me out. You ready? If you take -4, that's the first error. If you take a -4 and plug it in here, can you please evaluate inside of the square root? Do it again for me. -4. -1. Can you take the square root of a -1 and get a real answer? That's why it's an error. Okay? So only values of x that are greater than or equal to -3 will work. Okay, now, why did I leave this one to the end? X equals 0. Please do second trace value plug in 0 and press enter. If it's an irrational number, I'm going to round to the nearest hundredth. So negative 4.27. Done? Flip to the back side. Okay, be very careful. Every class that I've asked, the 2 initial people from each class have got this wrong. On your own, you have 4 questions. The questions are this. Write down if there's a reflection, if there's a stretch or compress, if there's a horizontal or vertical asymptote. On your own. 30 seconds, go. On your own. Renee, do you think there's a reflection? Yeah. Okay, tell me what you're going to tell me. What kind of reflection is it? What's happening? Okay, so you understand the concept. It's going to flip below. Now, how do we write that? It's going to reflect. And you can use the word across or the word over the x-axis. But Renee, you described it visually correctly. Okay, now this is where a lot of people are getting this wrong. You ready? Let's go with Andy. Can you tell me what you think the stretch is going to be? Stretch by a factor of negative 2. Is that correct? Burdette, do you agree? Yes. How many people also agree? Hands up high. How many people disagree? That's a really common mistake. Now here's the mistake. Really common. We've already used this negative sign. What does that negative sign describe? So we're done with that negative sign. That only describes a reflection. So when you think about a stretch, instead of saying negative 2, it's only going to be, so vertically stretch by a factor of 2. Vertically stretch by a factor of 2. Horizontal or vertical shift. Pablo, what is the horizontal shift? Okay, so are you moving 7 which direction? 7 to the left. How did you know that? Okay, but how did you know that this was horizontal and not a vertical shift? It's a tough one, Pablo. Don't worry. People in first and second also got that wrong. Here's the rule. Yes, do you want to take a guess, Carlos? Okay, so it's inside of the radical. So the number inside the radical represents horizontal. The number on the outside represents vertical. Is 7 underneath the radical? There's nothing there. So there's no horizontal shift. The vertical shift is up 7 units. Did anybody have the main concepts for those 4? 1, 2, 3, and 4. Hands up if you did. Nice job. Okay, so I want to show you how this works without using a graphing calculator. So stay, because we're not going to move left or right. Please move up 7 units and make a dot. That is your starting point, right? Okay, let's see what your memory is. What is the pattern for square roots? 0, 0, don't graph yet. 0, 0, 1, 1, don't graph. 4, 2, n. Okay, don't do anything. I'm going to write those down. 0, 0, 1, 1, 4, 2, 9, 3. Does everybody agree with that? Okay, now here's the deal. Instead of this graph now moving upward, instead of it moving like this, it's now going to go down. And not only is it going to go down, it's going to go down at a faster rate. It's going to move down because it's being vertically stretched by a factor of 2. So we're going to take and we're going to see what does this look like. It normally, watch this real quick. It normally would go over 1, up 1, right? Don't graph anything. But now it's going to go over 1, down 1. Still don't graph it. What is this distance? Take it times 2. And now it's going to go over 1, down 2. There's going to be an easier way to show you on a graphing calculator, and I'm going to show you over here in a second. So now, instead of going over 4 and down 2, 1, 2, 3, 4, okay? Before we went down, or we went up 2, now I'm going to go down 2. This is the original distance of 2. 2 times 2 is? Now go down 4. 1, 2, 3, 4. So now go over 9, which is right off the graph, and the parent function would say go down 3. I said that wrong, excuse me. The parent function would go over 9 and up 3. Because it's a reflection across the x-axis, we're going down 3. And 3 times 2 is 6. So now go down 6. Now before I show you the easier way to do it on a graphing calculator, again it's going down because of the reflection, and it's going to move down at a faster rate because of the stretch. Who was able to follow on how I came up with those points? Anybody here? Okay, about half the class. Now let's go over how do we do it quickly. Grab your graphing calculator, go up to your y equals. The negative sign is going to be below the 3, -2, square root of x, make sure to put a parenthesis after the x, and then plus 7. Okay, good? Does it look similar to ours? Yes. Okay, here we go. So now let's go back and finish these up. So domain is x's. Where does it start? What's the first x value it starts on? No, x. 0. Starts on 0 and it's touching 0 and it moves to the right. Now here's the most difficult part for students. Domain goes from left to right. Does range go top to bottom or bottom to top? And the reason for that is domain goes from your smaller numbers to your larger, and range goes from smaller to larger as well. So it comes from, what does it mean when this keeps going down and never stops going down? Comes from negative infinity, and it goes up as high as what y value? 7. And it touches 7. From left to right, is this thing increasing or decreasing? So put an NA for increase. Remember when we describe decreasing, we're describing it in terms of x values. It starts at x equals 0, and it continues to move to the right. So from 0 to positive infinity. So when you're finding the real zeros or the x-intercepts, y will equal 0. So I'm going to do a little mental math here, and then I'll show you how can we do it on the calculator to check. So let's put this y equal to 0. So 0 equals -2 times the square root of x plus 7. What's my first step? Subtract 7. What's the next step? I think I heard different things. What is it? Divide by -2, right? Okay, now you need to get rid of a square root. What's opposite of square root? Okay, so a negative divided by a negative is already a positive, and now I'm going to square it. What is 7 squared? And what is 2 squared? I have no problem with you leaving it as a fraction or a decimal. So let's check and see if this is correct. Go to your graph, go second, trace, value, and plug in 49 divided by 4 and press enter. Did you get the same thing I did? Okay, go back and hit window. Let's move this out to like 30. Let's try it again. Second trace, value, 49 divided by 4. Is that the correct intercept? Yes, it is. Do you see how it gives you in terms of a decimal answer? You are more than welcome to write it as a decimal answer. They're equivalent answers. To find the y-intercept, we're going to set x equal to 0. Second, trace, value, plugging 0 in for x and pressing enter, and the answer is 7. We could also visually saw that by looking at the graph. So 0, 7. With your partner, please fill in the end behavior. Only doing the top part, please. So as I move to the right, which way is it going? It's going down.